Of all the animal groups on Earth, the crustaceans are by far the most successful. Coming in a boundless array of colours, shapes and sizes, they have diversified so much that crustaceans are often called the insects of the oceans, a title reflecting their remarkable diversity and abundance. But nowhere are they more weird and wonderful than in the deep sea, where crustaceans have adapted in countless ways in order to survive and play key roles in the ecosystem. Let's take a closer look at these incredible invertebrates. As crustaceans are a subphylum of arthropods, meaning jointed feet, they display many jointed legs, as found on crabs and lobsters. Generally, crustaceans also consist of a head, thorax and abdomen, at the end of which is a tailpiece called a telson. But what sets them apart from other arthropods is 2 pairs of sensory antennae and at least 3 pairs of mouthparts. From mantis shrimps to copepods and the giant isopod, all crustaceans share these common features, giving them an evolutionary advantage over other animals. The antennae are used for making sense of their surroundings, as well as locating food and sensing danger. But in many species, we often find more unusual adaptations. Decapods, like crabs, have 10 walking legs, making them well suited to a benthic lifestyle down on the sea floor, where they scavenge for food. Contrastingly, euphorid shrimps like Antarctic krill have elongated bodies and paddle-like legs that help them swim through the open ocean, far from the sea floor. Under each eye, they possess light-producing photophores that they use to communicate via the phenomenon of bioluminescence. To survive in the expanse of the open ocean, krill have had to become filter feeders, consuming plankton that drift by on the currents. By repeatedly moving their appendages, water is drawn past the mouthparts, which are covered in fine hairs or setae. These form a highly effective food trap. The wonder of krill doesn't end there, for these tiny creatures also serve to demonstrate the important role that crustaceans play in the marine ecosystem. With their oil-rich bodies and tendency to gather in huge swarms so large that they can be seen from space, Antarctic krill are high-energy food able to sustain the enormous bulk of baleen whales, the largest animals on the planet, relying on one of the smallest. This shows that crustaceans are vital in the marine food web, but in more ways than just as a source of prey, as we're about to discover. There are no insects in the ocean, but crustaceans rule in their place and display an amazing variety of sizes and morphologies. Their role is very similar to that of insects on land. In addition to being a source of food, they occupy the role of detrivores, the deep ocean's cleanup crew. Most important are the amphipods, which you might have found leaping like fleas around washed-up seaweed on the shore. Even here, they are doing their job of cleaning up the stranded debris. And amphipods are found in every part of the ocean, from beach hoppers on the shore to 35,797 feet or 10,911 meters down in the furthest depths of the Mariana Trench. Here, the Hadal amphipod takes to the unlit stage, even possessing enzymes that are able to digest wood. They can and do consume just about anything that falls to the sea floor, filling an important ecological function by recycling nutrients from even hard-to-digest material back into the environment. Without them, the seabed would vanish beneath a deluge of dead plant and animal matter. These crustaceans can consume detritus at a rate between 60% and 100% of their body weight each day, for they are highly adapted to this task. Their legs have pincers with a movable half and a sharp edge used for tearing off pieces of food. In fact, bait that is sunk to the sea floor often comes back stripped to the bone by amphipods in just a matter of hours. Amphipods are important for another reason. Researchers have noticed that their size increases dramatically with depth, from a length of 8 millimeters in the shallows to over 34 centimeters long in the hadal zone of the ocean. This remarkable size is achieved by the species Alicella gigantea, a slow-moving scavenger which has been filmed clumsily stumbling into bait, latching on and gorging itself for hours. It exhibits the phenomenon of abyssal gigantism, but although it is far larger than many of its cousins, the supergiant is not so odd when we consider it has evolved to fulfill a niche that, in shallower water, is occupied by other large bottom dwellers like crabs, one of the most diversified crustaceans in the world. Amphipods are not the only crustaceans to exhibit gigantism. A relative of the land-dwelling woodlice, the giant isopod, can grow to 76 centimeters or 2.5 feet long. It too feeds on sunken detritus, clinging on with sharp claws and living at depths of 2,140 meters or 7,020 feet. Overall, crustaceans play a number of key roles in the deep sea ecosystem. From amphipods and isopods cycling nutrients from decaying material, to copepods parasitizing larger fish, and krill providing nutrients for some of the largest creatures on the planet, they are a diverse and ecologically vital group of organisms, capable of adapting in numerous ways to survive in every corner of the expansive deep sea. Today's video is sponsored by Babbel, the top language learning app in the world with more than 10 million subscriptions worldwide. What sets Babbel apart from most language apps is how well it prepares you for real-world situations, with lessons built by a team of over 150 real language teachers rather than AI. By using its full learning ecosystem, Babbel lets you decide which learning method suits you best, whether it's using podcasts, games, or live classes, avec beaucoup plus d'options à choisir. So, whether you want to learn a new language for your work, for school, or perhaps for an upcoming holiday, click the link in the video description to get 65% off. Begin your journey and start speaking a new language in just 3 weeks with Babbel. Au revoir, à bientôt.